Hello everyone, today we are going to discuss about Coulomb's law, or that is also called as electrostatic force. So here we are going to discuss about the basic thing regarding the Coulomb's law or electrostatic force, and also we are going to discuss one problem according to this Coulomb's law. So Coulomb's law states that suppose we have considered a 2-point charges. Suppose this is the Q1 charge and this is the Q2 charge, and distance between them is r. So according to the Coulomb's law, by using Coulomb's law we will measure the force between these 2-point charges. Why this is called as point charges? Because the distance between them, suppose here we have considered the diameter of 1-point charge. The diameter of 1-point charge is very small as compared to the distance between them, so that's why it is called as the point charge. So force which is directly proportional to the product of their charges, that is Q1, Q2, and force which is inversely proportional to the square of distance between them, that is the square of distance between them. So we can write the force which is equal to the 1 upon 4 pi epsilon 0 Q1 Q2 upon r square. Here we have considered these two-point charges in air or in vacuum. So this is the force in air as well as in vacuum. So this is our formula for force in air as well as in vacuum. Suppose we have considered same charges, we have considered this Q1 and this Q2 which having the same distance we have considered here. So just these two charges we have put in material medium. These two charges having the same magnitude and distance between them is r as we have considered here. So here is the just we have considered a material medium. Here we want to calculate the force because this material medium which having the dielectric constant which is greater than 1, and for air the dielectric constant in air or vacuum, that is for vacuum that is dielectric constant is 1, and for air that is 1.00 something, so that is approximately 1. So for air or vacuum we have considered as a is equal to 1, or for material medium which is greater than 1. So in material medium, suppose we want to calculate the force, so that force is in material medium which is directly proportional to the product of their charges Q1 Q2, and force in material medium which is inversely proportional to the square of distance between them. So force in material medium, that is equal to 1 upon 4 pi epsilon 0, additional quantity is K, is Q1 Q2 upon r square. So this is the formula for force in material medium. So only difference between in air or vacuum medium or material medium, there is the additional quantity, that is the K, which is greater than 1. So here we can say that when we have calculating the force in air or vacuum, that is always greater than the force in material medium if we have considered the Q1 Q2 charges and r distance same in material medium as well as in air medium. So in this way we will get the information that if we have considered the two charges, suppose Q1 charge we have considered as 2 Coulomb, Q2 charge we have considered a 3 Coulomb, and distance between them, suppose we have considered a 5 centimeter. Suppose this Q1 we have considered 2 Coulomb, here is we have considered 2 Coulomb, here is also we have considered 2 Coulomb. This Q2 we have considered 3 Coulomb, this Q2 also we have considered 3 coulomb, and distance between them, the distance between them also we have considered a 5 centimeter. Here is also we have considered a 5 centimeter. So when we calculating the force by using this equation 1 for air or vacuum, and here for material medium we are using this equation 2. So here we are, when we are calculating the force in air as well as in material medium, at that time we will get the greater value in air or vacuum as compared to the material medium, because this k is in denominator, so something divided by in denominator, so that's why resultant value also came in lesser value as compared to the this. So force in material medium is less as compared to the air or in vacuum. So now we will discuss one problem. So in this problem, 2-point charges in dielectric medium having a dielectric constant 5.2 interact with a force that is 8.6 into 10 to the power minus 3 Newton. What could be the force if the charges were in free space? So here what will happen? Here they have took the material medium. So they have took a material medium. Here they have put the 2-point charges, that is Q1. There is another charge Q2, which having the dielectric constant K is equal to 5.2, and here directly they have given the force in material medium, that is 8.6 into 10 to the power minus 3 Newton. So given data is that, given data we have given force in material medium, that is 8.6 into 10 to the power minus 3 Newton, and dielectric constant, that is 5.2, and we want to calculate the force in air. So we are familiar with that, the force in air, that is 1 upon 4 pi epsilon 0 Q1 Q2 upon R square, and force in material medium, that is 1 upon 4 pi epsilon 0 additional quantity is K Q1 Q2 upon R square. So here what will happen? Suppose we have seen that this is equal to force in air. So we can say that the force in material medium, that is equal to force in air divided by K, and here we want to calculate the force in air. So force in air, that is equal to force in material medium multiplied by K. So here force in material medium already we have given, and K value is also we have given. So this is the 8.6 into 10 to the power minus 3 multiplied by 5.2. So this become as, here we will calculate 8.6 multiplied by 5.2, this is 10 to the power minus 3. First we will calculate this. So 2 multiplied by 6, that is 12, here is the 1. So 8 multiplied by 2, that is 16, plus 1, that is the 17, plus is 5 multiplied by 6, that is 13, here is the 3. 5 multiplied by 8, that is the 14, 41, 42, 43. So this is become as 43. So we will get this 2, this 7, this 4, and this 4. So here is point 1, here is point 2. So we will subtract point here, and as it is this 10 to the power minus 3. So we will get the answer is 444.72 into 10 to the power minus 3 Newton. So we will get the answer 44.72 into 10 to the power minus 3 Newton. So this is the force in here, or also we can calculate, that is 4.472 into 10 to the power minus 2 Newton. So here just this point we have shifted here. So there is 10 to the power minus 3. Here we are on 10 to the power minus 2. So this is our required answer. Thank you.